Hello and welcome class. So in last class we have started a new chapter named Gravitation, and in last class we have concluded with saying that every object attract each other by a force known as gravitational force. It means that this pen is attracting me and I am attracting this pen by a force known as gravitation force, and this gravitational force is applied in whole the universe. Okay, moon is attracted toward you, earth is also attracted towards moon, earth is also attracted toward the sun, and earth is also attracted towards other planet like Jupiter, Mars, Mercury, etc. So all the objects are attracted toward each other by a gravitational force known by a gravitational force, and that force range is infinity. Okay, so a distinct star, let's suppose any distinct star like Alpha Centauri, which is around 3 light years away from me, is also attracting me, and I am also attracting that distant star. Okay, but uh, the distance increases, the force of attraction also decreases. So every object attract each other. Any distinct star is also attracting you, and you are also attracting the distinct star because of the third law of motion, uh, action reaction, that every action has equal and opposite reaction. If you are attracting any object, that object will attract you also. Clear class? And today, in today's class, we are going to start universal law of gravitation. Every object in the universe attract each other object with a force proportional to the product of their masses. Let's suppose these are two objects. One has mass m1 and other has mass m2, and both the forces are at has a distance d between both the object has distance d between them. Then what this is saying? This is saying that what will happen? Every object in the universe attract each other object with a force, and we are trying to find out that force. So we have assumed two object, one has mass m1 and other has mass m2, and both these objects are separated by a distance d. Then what the universal law of gravitation says? Universal law of gravitation says that the force is directly proportional to product of their masses and inversely proportional to the distance, the square of the distance between them. So these two equation will determine how much force will be, how much the magnitude of force will be there between two objects. Let's suppose m1 and m2 are very massive objects, okay, like earth and moon. Okay, these two are very massive objects. Okay, so the force of attraction will be very high. Okay, because force is directly proportional to product of their masses. Okay, if masses are very small, for example, the mass of this pen will be around 10 grams. The mass of this pen will be around 5 grams. So masses are very low. So there is not much force of attraction between these two objects. So force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It means that if the distance increases between both the object, the force of attraction will decrease gradually. Okay, how much closer these objects are, okay, more will be the force of attraction. If I separate and increase the distance between these two objects, then the uh, magnitude of the force will decrease gradually. So this is the first point of the universal law of gravitation, The second point of the universal law of gravitation is the force is along the line joining the center of two objects, and the direction of force will be the straight line joining these two masses. Okay, second point is the direction of the force will be the straight line between these two masses. These 2 points consist of universal law of gravitation. This is the diagram. Okay, two object, one object is A, one object is B. Okay, let's suppose A has mass capital M and B has mass small m. The distance between A and B is d. Then force is directly proportional to the product of their masses. Force is inversely proportional to the square of the distance between them. Then I can write force is directly proportional to m small m divided by d square by combining these two equations. Now, whenever there is a proportionality sign, whenever you want to really remove this proportionality sign, a constant will be occur, and that constant here is capital G, and this is the formula of gravitation, gravitational force, where G is the universal gravitational constant. Because we are talking about universal law of gravitation, so G is an universal constant. Okay. Two objects of mass small m, small b separated by a distance small d. Then we have calculated the force, and force come out to be, force is directly proportional to product of mass. Force is inversely proportional to the square of the distance between them. Then uh, force will be G m divided by d square, where the G is the universal gravitational constant. Okay, G is universal gravitational constant. Capital G is universal gravitational constant. Okay, what will be the SI unit of this G? We have to first calculate the SI unit of G. What is the SI unit of force? F. We have to is the SI unit of force? Newton. What is the SI unit of G? We have to calculate. Okay. What is the SI unit of mass? The SI unit of mass is kg. Mass is kg, so it will become kg square. And what is the SI unit of distance? Distance is meter square. Okay, because a square is here. So we will multiply meter square here and divide kg. So n m square divided by kg square is the SI unit of G. Clear, class? So this is the SI unit of universal gravitational constant, capital G. The value of G. Now, what should be the value of G? It was calculated by a scientist named Henry uh, Cavendish, okay, by a sensitive balance, a device sensitive balance, and he found out the value of capital G is 6.673 into 10 raised to the power minus 11 Newton meter square divided by kg square. You have to memorize this value, that the value of capital G is 6.6 into 10 raised to the power minus 11 Newton meter square divided by kg square. And because capital G is a universal constant, the value of capital G never changes. This is the value of capital G, which was found out by a scientist named Cavendish. We know that there exists a force of attraction between two objects. We know that there exists the force of attraction between two objects. Compute the value of this force between you and your friend sitting close by. Now, if I ask you to calculate the force of attraction between you and your friend sitting by, okay, let's suppose your mass is 35 kg. Your friend mass is 40 kg. The distance between you and your friend, suppose their distance is 1 meter. So you can calculate the force between you and your friend by using this formula. We know the value of G. The value of G is 6.6 into 10 raised to the power minus 11. The value of small m is 35. Value of capital M is 40. Distance is 1 square. Just simplify it and you will get the value of force of attraction between you and your friend. Because universal law of gravitation applicable in every body, so you can calculate the force of attraction between any two objects. Okay. So you can try this fun activity with your friends and you can conclude why you do not experience this force in our everyday life, because you can see the value of force is very small. Okay. If you calculate it, 35 into 40 into 6.6 into 10 raised to the power minus 11, the value of force will be approximately 10 raised to the power minus 9 Newton. 10 raised to the power minus 9 Newton is a very small number. Okay, very, very small number. So that's why you cannot experience this force in your everyday life, because the magnitude of force is very small. Clear, class? Okay, but we can every time sense the gravitation force between us and between Earth, because the mass of Earth is very huge. Okay, the law is universal. This universal law of gravitation is universal, so it is applicable on every body, every object present in our universe, from small particles to massive universal size celestial object, okay, or planet, stars. It is applicable on every object. Okay, now let's talk about that inverse square. In the formula of force, force is inversely proportional to distance square. Let's talk about it. Saying that F is inversely proportional to d square means if the distance is getting bigger by the factor of 6, let's suppose your new distance is 6 times the older distance, then your force will be 1 by 6 d square, which is 1 by 36 d square. It means the force will decrease 1 by 36 times the original force. Okay. So force decrease very fastly if you increase distance between two objects. Okay. Is it clear, class? Let's solve some example to understand this formula more accurately. The mass of Earth is 6 into 10 raised to the power 24 kg. It's a very huge number. 6 into 10 raised to the power 24 kg. And that of the moon is 7.2 into 10 raised to the power 22 kg. This is the mass of moon. Okay. If the distance between Earth and moon is 3.8 times 10 raised to the power 5 kilometers, calculate the force exerted by Earth on moon taking G 6.7 into 10 raised to the power minus 11. Okay. So the mass of the Earth M is 6 into 10 raised to the power 24 kg. The mass of moon, let's suppose it is small m, is 7.4 into 10 raised to the power 22 kgs. The distance between mass Earth and Moon is 3.8 into 10 raised to the power 5 kilometers. We have to convert it in meter. Then we have to calculate the force of gravitation between these two objects. How we are going to calculate it? We know the formula of force. The formula of force is G-M-M divided by D square. We know the value of G. We know the value of capital M, small m and D. We just have to do calculation and convert distance in meters. Then we can calculate the force in term of Newton. Clear, class? So I hope the approach is clear to all of you. Let's do the calculation part. So mass is given, mass of Moon is given, the distance between Earth and Moon is also given. Okay, 3.84 times. Okay, 3.84 into 10 raised to the power 5 times 1000 meter, because we are converting kilometers into meter. The final answer is 3.84 into 10 raised to the power 8 meter. This is the value of gravitation constant. 6.7 into 10 raised to the power minus 11. Now we will put the all values in the formula. The value of capital G is 6.7 into 10 raised to the power 11. The value of capital M is 6 into 10 raised to the power 24, and the value of small m is 7.4 into 10 raised to the power 23. The value of distance is 3.84 into 10 raised to the power 8 square. Now how to solve these type of problems? To solve these type of problems, first take all the numerical value on one side and take all the 10 to the power values on the other side. So we have 6.7, we have 6 and we have 7.4. Multiply by 10 raised to the power minus 11. Then we have 24, so plus 24. We have 22, so plus 22. Divided by 3.84 square. So it will be 2 times into 10 raised to the power 8 into 2 is 16. Now simplify constant on one side and simplify all the power thing on another side. 11, 30, 6.7 into 6 into 7.4 divided by 3.84 into 3.84. Multiply by 10 raised to the power 35 into 10 raised to the power 16. Let's simplify it. This will come above and get a minus sign. Sign changes. Ten raised to the power 19. Okay, now you have to simplify it and get answer in a standard form. This is the standard form. A numerical value, then decimal, then other numerical value, multiply by 10 raised to the power, okay, Newton. So the force of attraction between Moon and the Earth is approximately 2 into 10 raised to the power 20 Newton, which is a very huge number. Clear, class? It's a very huge number. And why it is so? Because the mass of Earth and mass of Moon are very huge. Okay, now let's solve some question. The question number 1 is state the universal law of gravitation. What is universal law of gravitation? Universal law of gravitation is when two objects of mass m1 and m2 separated by a distance d, then force is directly proportional to the product of their mass. Force is inversely proportional to distance square, and the direction of the force will be the straight line joining these two masses. This is the universal law of gravitation. I hope this is clear to you. Now let's see its detailed solution. Universal law of gravitation states that every object in the universe attract every other object with a force called as gravitational force. Okay. All the objects in the universe attract each other by a force known as gravitational force. The force of attraction between two objects is directly proportional to the product of their masses. Directly proportional to the product of their masses, inversely proportional to the distance between them. Clear? Question number 2. Write the formula of to find the magnitude of gravitational force between Earth and the object on the surface of the Earth. You have to write the formula to find the gravitational force between Earth and object on the surface of the Earth. And how you're going to calculate it? Now we know that this is our Earth and this is the surface of the Earth and the radius is r. Let's suppose the mass of Earth is capital M, the mass of object is small m, and distance between them is r. Then force will be G capital M small m divided by r square. This is the formula for force, gravitational force between Earth and any object which is put on the surface of the Earth. Let F be the force of attraction between Earth and an object on its surface. Assume that ME be the mass of Earth, ME be the mass of Earth, and small m be the mass of the object. Okay, and this will be the formula for the force between Earth and that object on the surface of the Earth. Is it clear, class? I hope this question is clear to all of you. Now, next topic is, what is the importance of universal law of gravitation? So, universal law of gravitation help us to explain why we are attracted towards Earth, why moon revolve around the Earth, why planets revolve around star. Okay, so these type of phenomena are explained by universal law of gravitation. There are other phenomena also, like why tides, okay, high tides used to form in on sea, and the reason is also gravitation, and we are going to learn about it. So these are the importance of universal law of gravitation. Number 1 is the force that bind us to Earth. Number 2, the motion of moon around the Earth, the motion of planets around the sun or the star, because sun is also a star, and why tides are formed due to tides. This is Earth. Let's see, it's a Pacific Ocean, or let's suppose it's Indian Ocean. And here is the moon. So the gravitation force of moon attracts the seawater towards it, and because of it, high tides are formed on the surface of the Earth. Okay? So gravitation force is responsible for the high tides on oceans of our planet Earth. So I hope these points are clear to you. These points tell us the importance of the universal law of gravitation. So in today's class, we have studied what is the universal law of gravitation, the formula of the force of attraction between two different masses. We have solved some problems and we have concluded this topic by understanding what is the importance of the universal law of gravitation. So I hope today's class is clear to you, and now we will meet in next class. Thank you.